My name is Aaron Willette, and I'm in the Seattle office at Arup. And I'm on the Acoustics, Audiovisual, and Theater Design team. I specialize a little more in the room acoustics area. And I've also taken a pretty strong interest in the Auralization work we do in our sound lab. And so I manage Seattle's sound lab, and I'm always kind of looking at new tools for sound simulation, modeling, Auralization, to kind of make sure that we're on the cutting edge of that. Design of buildings is so complicated and multifaceted that you can never really rely on anything. And that requires you to just be really flexible and open and not get rigid and stuck on any one particular design, and that's just a really healthy mindset to be in. I think the biggest misconception that people have about acoustics is that it only applies to specific types of jobs or specific types of buildings where people can immediately think of acoustics. Say concert halls, performing arts spaces, where obviously acoustics is extremely important, but I don't know, acoustics is for everyone. Like, if you don't like hearing your neighbor walking around above you, if you want to be able to understand someone who's talking through an amplified system anywhere, if you want to not hear noise from the street or from outside or from planes going overhead, that's all acoustics, and that applies to everybody. And some of the biggest quality of life things that people complain about or are annoyed about in their everyday life are often acoustics. Back in the day when acoustics first kicked off, it was very much kind of vibes based, or at least just based on past projects and precedent and things that were known to work, even if it wasn't known why they worked. And then you would get halls that were kind of designed the same way, and you have like a few different genres of halls that were kind of all designed. You know, maybe you got your long, thin lecture halls that were all designed a certain way, and then you've got your kind of Shakespeare-style opera houses that were all designed a certain way. But there wasn't as much freedom to be creative in the design because you had to go on past precedent, and you couldn't trust necessarily as much science that existed at the time. So what made us initially interested in Treble for our work is two main areas, and the first is the wave solver, and the second is the ease of use. In some ways it's less of an art and more of a science, but then it kind of wraps back around to being art again because you can be creative in your design because you know that you can actually validate it and you're not just taking a huge risk.